Hello everyone, let's look at Leetcode question 125, valid palindrome. At time of recording, this question has 8.8 thousand upvotes and 8.2 thousand downvotes. The question is, a phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumerical characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. So, let's not get confused. So alphanumeric characters are letters and numbers, and non-alphanumeric characters are everything else. So spaces, exclamation points, semicolons, you get it. So given a string S, return true if it is a palindrome or false otherwise. Okay, let's look at the constraints, then the example. So the string input length will be between 1 and 200,000 characters, and S consists only of printable ASCII characters. Okay, to solve this problem, we're going to use the isAlNum method, and this returns true if all characters in the string are alphanumeric. Alphanumeric means all letters and numbers. The lower method returns a string where all the characters are lowercase, and this is needed to satisfy the condition that the string must have all lowercase characters and all alphanumeric characters. So let's run really quickly through this code and then check with an example. We're going to define all L and R. So these are the index values of the string input S. R will be on the end of the string S, starting at the final index, and L is the beginning index. And we will increment the L and subtract from the R until L is no longer less than R. But while L is less than R, we're going to loop and check. While L is less than R again, and not character at isAlNum method. So this just checks that the index character L is less than R still, and that the value of the character itself is actually a non-alphanumeric character. Because of this not, it's going to make it so the current character is either checking for any spaces or exclamation points or question marks, non-alphanumeric. Okay, so if it is true and this is a non-alphanumeric character, we're going to increment L by 1 to then move to a next character which will hopefully be alphanumeric. Same thing for the right index characters of the string. We're going to check if L is less than R and that the current character is non-alphanumeric. If it is, then we will subtract from R. And finally, we have arrived at characters that are both alphanumeric. So we check if this character is converted to lowercase, and if it's not equal to the right character converted to lowercase as well. If it is a palindrome, these should be equal. So if they're not, we return false and we exit the program. But if they are palindromic, then we can move to the next character. So L plus 1, R minus equals 1. Until finally the while loop is finished and we return true. Okay, so this first example, you have a man, a plane, a canal, and Panama. So we start with the while loop. Index L is at 0 and R is at index A. While L is less than R, 0 is less than the length of this minus 1. This is definitely true. And then we check while L is less than R and not a palindromic character, we increment. So A and A are both palindromic, so we don't worry about these two while loops, and we check then A converted to lowercase is A, and then the opposite A converted to A lowercase. This is true, these are equal, and we return no false. We then increment to the next character, and it's a space here, and the next character is a M here. So we do this while loop again, and then we say, okay, we increment L by 1 because M is the next character that is a palindromic character. And we say M is equal to M. M is equal to M. And we continue this process until just every single character is equal and the return false statement is never met. And this is the case actually for this problem because all of these characters are equal after removing all non-palindromic characters. So we return true. For this example, it's a little shorter so we can go through it. Race a car. Okay, so we start at R and R, and going through the loop, we say, okay, L is less than R, and both are palindromic, so we don't worry about these while loops, and we check these two characters in lowercase if they're equal or not. They are equal so far, so we increment A to A. These are also equal, so we increment C to C. Equal as well, so we increment E to space. Okay, so for the E, it's a alphanumeric, so we don't need to increment L plus 1. But the character is a space for R, so this is non-alphanumeric, so we actually move the pointer one to the left to access the next palindromic character, which is an A. Okay, then we check if SL to lower is not equal to SR to lower, so this is the E and the A. They're both lowercase and they're not equal, so we return false. Okay. Here's the last example. Let's check really quick. WW, we start LR, while L is less than R. These are both palindromic characters, or alphanumeric, sorry, and we don't then increment the pointers. So then we check if these lowercase characters are equal. They are, so we increment. A is equal to A, S is equal to S, space. In this while loop, we increment the pointer to the I, and same for the pointer here, which becomes I as well. Two lowercase, they are equal. TT, AA, that space is pointing to the next character, which is A, and that A's checked with the A, they're equal. Okay, and then finally C. Okay, and we could see that the character for C is also equal to C because they arrive at the same character. This is equal, so we simply increment then once more and we exit the while loop because L becomes greater than R, and this means that we can exit, so we return true. So true. Okay, let's check the solution. And it works. Very nice. So the time complexity of this code is O of n, where n is the length of the string s. This is because the code iterates through the string once, comparing characters at each step. The space complexity is O of 1, because it uses a constant amount of additional space, regardless of the size of the input string. That's it for this question. Thank you for watching.